section 14.4, we're going to take a quick break from trigonometry and talk about vectors. But don't worry, when we study vectors in a little more depth in 14.5 and 14.6, we'll go back to using some trigonometry. So this is just a quick interruption for us to understand what a vector is. So we're going to think of a vector as some quantity that's going to have both magnitude and direction. So when you think about your car and you think about the speed that your car is driving, you're only worried with what that speedometer is saying. But if you're giving directions to somebody, you would want to describe how far and in what direction that they needed to travel. So if you needed to go 3 miles south on a particular road, you would need to have both the number of miles and which direction you were going in. That would be an example of a vector. Now, we can also talk about displacement of an object, and that's just describing where something starts and where something ends. And so here we need to know the direction that that object is traveling, as well as how far it is from the starting point. So we can think of vectors as ultimately describing the displacement of an object, because we'll know that you've got some starting point, and if you go in a particular direction for a particular distance, you'll end up in the ending point, and that is your displacement. So we're going to focus on addition of vectors here. We're going to be looking at what happens when you have one vector, then another, and then another. Think about this again like driving. If you go 3 miles south and then 2 miles east, then 1 mile south again, and then 3 miles to the west, where are you when you end up? So let's look at this example. We have an air traffic controller at a New York airport who instructs the pilot to fly a jet 300 miles due west, then turn and fly 400 miles due south. So the first question, how far did the jet travel? Well, they went 300 miles, then 400 miles, and so the total would be 700. But maybe we're not interested in the total distance they traveled, just how far away they are from the starting point. So if we start here in New York and we go 300 miles due west, and then take a turn and start heading north, and we go 400 miles, then how far are we from the starting point? Really, if we had just gone there directly, how far would that have been? Well, you should see that this is a right triangle, and so we can solve 300 squared plus 400 squared equals our hypotenuse squared. When you add this together, you're going to get 2,500. Now you're going to get a little bit more than that. You're going to get 250,000 miles. And then when you take the square root, you're going to see that the ultimate displacement was 500 miles. So we have two things that we're considering here. We're considering the total distance traveled, and then we're also considering the total displacement. And those are two different things. Now, some notation. Typically, vectors are going to be in boldface, and magnitudes are just going to be written in italics. But you might find it very hard to write in italic and bold when you're writing. And so typically, if we're writing a vector, we'll put a little arrow over it in our handwriting, and then otherwise we will not put an arrow if we're just referring to a magnitude. Now, the method that we're going to use to add vectors is this tail to head method. And ultimately, that's what I did in example 3. I drew a vector going in the west direction, and then I started my vector at the arrow side, and then drew it moving in the north direction. So if we have some vector, we've got our tail, and then our head, and then we can draw another one. We want its tail to its head. And that's how, when we want to add our two vectors, so let's say we have vector B and vector C, the result here, when I add them, is ultimately just what would have happened if I had gone directly from one to the other. In your homework, you're going to be putting some of these vectors together, And when you add them together, just remember you take one vector, and then wherever that arrow ends up, you take the second vector, you add them together by finding the start of the overall drawing to the end of the overall drawing, and that is going to be the addition of those two vectors.